Voyager's dangerous change. New data from the Voyager spacecraft reveals a troubling transformation beyond the edge of the solar system that scientists never anticipated. In 1977, when the world had no internet, no smartphones, and no one was talking about artificial intelligence, humanity quietly launched two small spacecraft away from Earth. Their names were Voyager. No one could have imagined that 47 years later, while countless modern technologies had already become obsolete, these machines, built from metal, cables, and old magnetic tapes, would be more than 24 billion kilometers away from us, and still whispering extraordinary information back to Earth from the darkness of interstellar space. They carried no humans. They cannot turn back. They will never return. Yet, these lonely messengers have seen what no one had ever seen before, forcing science to rewrite what we know about the solar system, about space, and about humanity's place in the universe. So the question is, what exactly did Voyager discover that changed everything? If you love stories about the universe like this, subscribe to the channel so you won't miss journeys that go even farther than Voyager. Voyager is not just a machine traveling through space. It has no emotions, no consciousness, yet it carries the human spirit more than any other man-made object ever created. Within every circuit and every line of code lies an unending curiosity. The same curiosity that has always driven humanity to ask, what lies beyond the sky? In every bold engineering decision, there is courage. The courage to send a spacecraft into the unknown, with no certainty of what it might encounter. And in the fact that Voyager is still operating after more than 4 decades, we see extraordinary resilience, a reflection of humanity's own long journey of survival and progress. Today, Voyager stands as Earth's most distant ambassador, a quiet greeting sent from our small planet into the vast universe. No spacecraft, satellite, or human-made object has ever traveled farther. And perhaps nothing will surpass it for a very long time to come. At first glance, Voyager should never have made it this far. Its onboard computers are far weaker than the chip inside a modern car key. They have less memory than a digital watch. And instead of solid-state drives or cloud storage, Voyager still relies on magnetic tape technology from the 1970s. By today's standards, this technology is not just outdated, it is almost unimaginable. And yet, this very primitive design is exactly why Voyager survived. Deep space is not friendly to modern electronics. Radiation is relentless. Temperatures are extreme. Repairs are impossible. Older technology built with simplicity, physical robustness, and redundancy turns out to be far more resilient than fragile, high-density modern systems. Voyager's systems were designed to do one thing at a time, slowly, predictably, and reliably. No unnecessary complexity. No dependence on constant updates. In deep space, simplicity is strength. This is the great paradox of Voyager. Technology that looks ancient on Earth became nearly indestructible at the edge of the solar system. Sometimes, to go the farthest, you don't need the newest tools. You need the right ones. At first, Voyager was never designed to travel this far. NASA's original plan was fairly modest, a 5-year mission to fly past Jupiter and Saturn, capture images, collect data, and then bring the journey to an end. But in 1977, the universe offered humanity a rare opportunity that appears only about once every 176 years. The giant planets of the solar system aligned in an almost perfect configuration. This alignment allowed Voyager to use the gravity of each planet like a cosmic slingshot, gaining speed and changing direction without carrying additional fuel. When Voyager completed its original mission with remarkable success, a bold question echoed through the control room. Why not keep going? And so the plan was expanded. Voyager would not only visit Jupiter and Saturn, but continue on to Uranus, Neptune, and beyond, toward the outermost regions where the sun's influence slowly fades. That moment transformed Voyager from a planetary mission into a historic journey toward interstellar space. Voyager's extraordinary success was not the result of luck, but of exceptionally wise engineering choices and the rare long-term vision of NASA's engineers. First came the power source. Each Voyager carries an RTG, radioisotope thermoelectric generator, using plutonium-238. As this isotope decays, the heat it releases is converted into electricity. No sunlight required, no rechargeable batteries, only time. This system allowed Voyager to operate continuously for decades, even in regions where sunlight is nearly useless. Next was the strategy of gravity assist. Instead of hauling enormous amounts of fuel, Voyager cleverly borrowed the gravitational pull of the giant planets to accelerate and redirect its trajectory. As a result, it reached speeds no rocket could ever achieve on its own. Voyager's design also emphasized redundancy and flexibility. Many instruments had backup copies. Systems could be turned on or off individually to conserve power as energy slowly declined. And finally, there was the antenna. Voyager's transmitter is only as powerful as a light bulb inside a refrigerator. Yet thanks to near-perfect pointing accuracy, that faint signal still travels tens of billions of kilometers to reach Earth. This fusion of durable engineering and vision far ahead of its time turned Voyager into one of the most successful machines humanity has ever built. When Voyager approached Jupiter, scientists believed they already understood the giant planet quite well. But with the very first images sent back, those assumptions began to collapse. Instead of a stable atmosphere, Jupiter revealed itself as a vast ocean of storms, swirling cloud bands, gas streams moving in opposite directions, and storms larger than Earth itself constantly collided, separated, and merged. Jupiter's atmosphere was anything but calm. It was alive, chaotic, and violently dynamic. Voyager also confirmed a surprising fact. Jupiter has its own ring system. Though faint and thin compared to Saturn's, this discovery forced scientists to accept that rings are not exclusive to a single planet. But the greatest shock came from Io, a moon once thought to resemble Earth's moon, cold, silent, and scarred by impacts. Voyager proved the opposite. Io is the most volcanically active world in the entire solar system. Towering plumes of material shooting hundreds of kilometers into space were captured in the act of eruption. Then came Europa. Its icy surface was crisscrossed by long, complex fractures. Voyager's data offered the first suggestion that a vast subsurface ocean might exist beneath the ice. With a single visit to Jupiter, Voyager transformed its moon system into one of the most promising places to search for life beyond Earth. If you had to choose one place beyond Earth that could support life, would you choose Europa, Enceladus, or another world? Let us know in the comments below. Before Voyager reached Saturn, scientists believed they had a solid understanding of the planet famous for its magnificent rings. Once again, Voyager proved them wrong. What were once thought to be 5 simple rings turned out to be hundreds, perhaps thousands of thin ringlets, interwoven, separated, and constantly in motion. Saturn's rings were not peaceful structures, but a dynamic, chaotic system continuously stretched by gravity and motion. Voyager also confirmed the existence of shepherd moons, small moons such as Prometheus and Pandora that help keep narrow rings from dispersing. They act like invisible conductors, constantly sculpting the ring's shapes. Another stunning discovery followed. Saturn's rings are slowly disappearing. Under the planet's gravity, ice and dust fall inward like a slow but irreversible cosmic rain. Then came Titan with its thick, nitrogen-rich atmosphere, and Enceladus, an icy world bursting with activity. Voyager's early data planted a bold idea: life may not need to resemble Earth in order to exist. Saturn, once merely a symbol of beauty, became a living laboratory of the universe. As Voyager left Saturn and pushed deeper into the darkness, it encountered the two strangest worlds in the solar system. Places that forced science to admit that familiar rules no longer applied. First was Uranus. The planet is tilted almost sideways, rolling through space as if knocked over. But the true shock lay not in its tilt. It was the magnetic field. Voyager discovered that Uranus's magnetic field is dramatically offset, tilted nearly 60 degrees from its rotation axis and not centered within the planet. This shattered existing models of planetary magnetism, which assumed these axes should nearly align. Then came Miranda, a small moon that looked as though it had been torn apart and stitched back together. Its surface is a bizarre patchwork of ancient cratered terrain and sharp, youthful structures. Towering cliffs and deep valleys make Miranda appear like a sculpture carved repeatedly by the cosmos. Finally, there was Neptune, a distant blue world of astonishing violence. Voyager measured the fastest winds in the solar system, exceeding 2,000 kilometers per hour. Despite receiving little energy from the sun, Neptune remained shockingly active. Uranus and Neptune proved a humbling truth. The universe does not need to resemble Earth to be alive with motion. In 1990, when Voyager 1 was more than 6 billion kilometers from Earth, scientists prepared to permanently shut down its cameras to conserve the last remaining energy. Then a suggestion arose: turn back and look home one final time. From the edge of the solar system, Voyager captured a brutally small image. Within a faint beam of light, Earth appeared as a tiny pale blue dot. Everything we have ever known exists within that speck. Every human who ever lived, every war, every love, every belief, every pain, and every hope unfolded on that fragile point of light in the vast darkness. Carl Sagan said, "That's here. That's home." The image contained no new scientific data, yet it changed how humanity sees itself. We are small, but also unique. And in the immensity of the universe, Earth is not just a planet. It is everything we have. When you see Earth as such a tiny dot, do you feel insignificant or more deeply connected to everyone who shares this planet? Leaving the planets behind, Voyager entered an invisible frontier between the solar system and interstellar space. This was not a wall, but a series of complex transitional regions. The first was the termination shock, where the sun's supersonic solar wind suddenly slows as it collides with interstellar matter. Next came the Helios Heath, a turbulent buffer zone where particles compress, heat up, and swirl. Finally, there is the heliopause, the boundary where the sun's influence ends. Before Voyager, scientists imagined the heliopause as a smooth, stable shell. The data told a different story. This boundary is rough, fluctuating, and chaotic, more like a sea of magnetic waves than a clean surface. In 2012, Voyager 1 crossed the heliopause, becoming the first human-made object to enter interstellar space. 6 years later, in 2018, Voyager 2 followed, confirming that this boundary is far from fixed. That discovery alone forced science to rewrite models of the solar system's protective bubble and reshaped our understanding of how stars interact with the space around them. Time spares no machine, not even Voyager. As power slowly declined, problems began to appear. At times, data became meaningless. At others, the signal fell silent, as if the spacecraft had vanished into eternal darkness. The challenge was distance. Voyager was more than 20 billion kilometers from Earth. Each command took 22 hours to arrive and another 22 hours to receive a reply. No hands-on repairs, no quick trial and error. Every decision was a gamble against time. NASA engineers analyzed every fragment of data, formed hypotheses, and sent carefully crafted command sequences, only to wait in silence for nearly 2 days. And again, Voyager answered back. The signal was faint, but it was still there. Those rescue moments were not just victories of engineering, but proof of human patience and perseverance. Voyager is growing old, but it refuses to stop. One day, Voyager will fall silent. Its last energy will fade. Instruments will shut down. Systems will slip into darkness. No more signals, no more data, no more replies reaching Earth. But Voyager's journey does not end there. The two spacecraft will continue drifting through space for tens of thousands, perhaps hundreds of thousands of years, passing distant stars, crossing regions no human will ever visit. Attached to them remains the golden record, a collection of Earth's sounds, ocean waves, children's laughter, greetings in many languages, and the music of humanity. It is not a scientific message. It is a whisper that we once existed, that we loved, dreamed, and tried to understand the universe. And perhaps one day, another intelligence will hear that whisper. Who do you think will be the one to hear Voyager's message? If one day another civilization finds Voyager and listens to the golden record, what do you think they will understand about humanity? Share your thoughts in the comments below.